Hello guys, if you're in grade 11 or 12 and you want to understand more about Newton's second laws of motion, well, this is a correct video for you. So these are those types of questions that a lot of people do not do. So today I'll be trying to answer it and to ensure that you get more understanding about it. Well, you can support us by sharing this video to as many people that you know that this would be helpful. And please like, share, and comment, and also repost our post so that many people can actually know and understand this topic. Otherwise, let's actually get down to it. So this question says, a man applies a constant pulling force on a heavy parcel of mass 50 kg. So we can actually see the man that is actually pulling this heavy parcel of mass 50 kg using this pulley system, and this block happens to be on top of some sort of a table, right? And they say he is using a light intensive rope which passes over a light frictionless pulley as shown in the diagram below. The coefficient of static friction, this is the most important part of the question, the coefficient of static friction, right? The coefficient of static friction. So because this friction is static, it means that this thing, it is not moving, right? So it means that this thing, it is standing. So when it is standing, we know that it means that F net actually equals to 0, right? The acceleration is 0 because it is not moving. So F net actually equals to 0. And then they say that the rough table surface is 0.34. So this is the coefficient of the static friction, right? So they say the magnitude of the maximum static frictional force is 120 newtons. So the static frictional force, it's actually 120 newtons within this table, right? Now let's actually try to answer this question. So the first question that we have is, it requires us to do what? It says, draw a free body diagram of the parcel. So we need to draw a free body diagram of the parcel. So this is how I would advise you to do it. First, you're going to draw a wonderful dot. This dot represents this parcel, right? And then the second thing, what do we know? We know we always have got the gravity, right? That is always pointing downwards. So because this thing is actually standing, but however we do have the static friction, and because this thing is being pulled into this side, we know that the static friction is actually acting on the opposite direction. So we do see this rope actually acting on this angle. So we do know that we are going to have this force here, and it is actually the tension force. If you want to make this more variable, you can actually show that within here we have got the theta, and then finally we are going to have the what? We're going to have our normal force. So that would be how you actually draw your free body diagram for this question. And now the following question, what does it require us to do? It says when the when the static frictional force is at its maximum, show that the magnitude of the vertical component of the tension force in the rope is 137.06 newtons. So the question is actually saying that we need to find Ty. This is what the question is saying. The question is saying we need to find Ty. So how do we actually find Ty? How do we do it? Well, we do remember that we were given friction and the coefficient of the static friction, right? So what we're gonna do is, we know this formula, Fs equals to mu s times the normal force, right? So the friction that we were given was 120 newtons, and then the coefficient of the static friction was 0.34. So it means that we can actually use this information to find the value of the normal force, right? So I'm just going to divide both sides by 0.34, and then I am going to get the value of the normal force to be 352.94 newtons, right? So what do I know? I now know the value of the normal force, that it is 352.94 newtons. And they want me to find this Ty. Okay, let me look at the sum of the component or the forces in the Y component. Because this thing is not moving, we know it is going to equals to 0, right? So what do we actually do? We are actually going to say, okay, on the Y component, we have got the normal force. Can you see this? So I'm going to say, okay, 0 equals to, we have got the normal force. Because we also have got Ty on the Y component. On this Y component, we have normal force. We have got also Ty. I'm going to write Ty, right? And then we also have got what? This thing will have a minus gravity. So why is gravity negative? Because if you look into a Cartesian plane form, this is in the positive side, this is in the positive side, but this is actually on the negative side. That's why it's a minus, right? So we are trying to find Ty. So it means that Ty will equals to, gonna take this to the other side, minus Fg, the normal force to the other side. We're gonna have minus N, right? And then we ask ourselves, what is Fg? Fg is going to be Fg is actually going to be 50, because remember the force, the mass of the of the parcel is 50 kg, time is 9.8, and then we're also going to minus 352.94 newtons. Oh, by the way, I just realized that the Fg is going to be positive, right? Because it is a negative, so it's going to be a positive. So our Ty, we're going to hit this in the calculator. We're gonna have 50 times 9.8 minus 352.94, and we get a value of 137.06 newtons. And this is exactly what they wanted us to show, that it was 137.06 newtons, and it is 137.06 newtons. And now the questions that follow says, calculate the magnitude of the tension T. So they now want us to calculate the magnitude of this tension force, right? So they want us to calculate the magnitude of the tension force. So how do I actually do that? Well, at this point, we do know a couple of things. Ty, we do know is the same as the T sine of theta. It is going to equal to 137.06. That is what we know, right? But let's actually look at the forces on the x direction. Let's try to look at the forces on the x direction. This is the forces on the x direction. So I'm going to say the sum of all the forces on the x direction also has to equals to 0, because this thing is not moving. We're going to have 0 equals to minus T, the cos of theta. This is minus because if you look at it in terms of a Cartesian place, it's on the minus side. It is going to equals to a positive Fs, because it's actually on the positive side of the Cartesian plane. And then we are going to make T cos of theta subject of the equation. So T cos of theta is going to equals to Fs. But what is Fs? Fs is 120 newtons, right? It is actually written here on our statement that it is actually 120 newtons. Now, if I divide both sides by the cos of theta, I'll only be left with T that equals to 120 divided by the cos of theta. So this is going to be my equation number 1. But well, when I actually go back here, I'm also having the T sine of theta that equals to this. So it means that if I divide both sides here by the sine of theta, I'll be having T that equals to 137.06 divided by the sine of theta. This will be my equation number 2. So as you can see, equation number 1 and equation number 2 have some stuff, but the constant, the thing that I have in common is the value of t. So it means that we are going to equate these two equations, right? So I'm going to write this 137.06 divided by the sine of theta is going to equals to 120 divided by the cos of theta. So, how do I actually move from here? So I'm just going to cross multiply. I'm going to take, in fact, I want to make things to be easy for me. So I'm just going to take this sign and cross it here, right? And then take this number and cross it here. So it means I'll have 120, the sine of theta, and 137.06, the cos of theta. So if I divide both sides by the cos of theta, you see, I'll have 120. This will change to be the tan of theta. That equals to 137.06. And then I'll divide both sides by 120. So I'll have the tan of this. So now let me try to find theta, right? Let me find theta using my calculator. So I'm going to say the tan of theta is 137.06 divided by 120, and then I get my theta to be 48.8 degrees. So remember, I want to find t, so it means that I'm going to substitute theta in here or in here, in whatever one I'm going to get the value of t. So let me just substitute theta here. I'm just going to substitute 48.8 degrees. I'm going to use this. So let me just show you. I'm going to say 120, the cos of 48.8. I'm going to add 182.18. So it means that my tension is 182.18 newtons. So well, that was how you actually calculate this question.